Okay, this is the 2025 free response questions for AP Calculus AB exam. I'm going to go over number 3 and how I would solve this. Would like to note that not only is this number 3 from the AB exam, it was also number 3 from the BC exam. So number 3 says a student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differential function r, where r of t is measured in words per minute. Selected values of r of t are given in the table shown. Part A says approximate r prime of 1 using the average rate of change of r over the interval of t between 0 and 2. Show the work that leads to your answer and indicate units of measure. Okay, so starting with A, I need to find r prime of 1, and using the average rate of change, I'm going to take my two values in my table for r of t, subtract them, and then divide them by the two values in the table for t, and then subtract them. So I have 100 minus 90 over 2 minus 0, which gives me 10 over 2, which gives me 5. And then in order to look at the units, notice that I used r of t values first, and that's words per minute. And then I'm dividing by the minutes, so technically my answer is words per minute squared. So words per minute squared. Part B says, must there be a value c for 0 less than c less than 10 such that r of c is equal to 155? Justify your answer. So we're going to do part B. Okay, so first, we know that that there is a derivative for r of t because we're given the derivative of r prime 1. So r of t has a derivative, r prime of t, which implies that this function is continuous. Okay. I'm then going to check both ends of our r of t value. So for example, I'm going to check r of 0, which is 90, and I see that 90 is less than 155, the value of r of c. And I'm going to check the opposite end, so that's r of 10, which is equal to 162, is greater than 155. So by the intermediate value theorem, there exists a c that belongs to 0 and 10, such that r of c is equal to 155. Part C. Use a trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate the value of the integral of 0 to 10 r of t dt. Show the work that leads to your answer. Okay, so the integral of 0 to 10 of r of t dt is approximately, and what I'm doing here for the trapezoid formula is I am looking at the distance between the t minutes in the table. So I'm going to go up here and I see that the distance between these is 2, distance between this is 6, and the distance between this is 2. And then I'm going to take the r of t values for each of them. So for example, these two here, okay, I'm going to add these values together and divide by 2 to find that average. Okay, so for my answer, I'm writing this as 2 times 90 plus 100 over 2 plus 6 times 100 plus 150 over 2 plus 2 times 150 plus 162 over 2. And you could try to solve this out if you want, but If you're afraid that you're gonna make any mistakes, you could leave this as is. Just make sure you label it with the correct units, and in this case would be words. And then part D says a teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function w, defined by w of t is equal to negative 3 over 10 t squared plus 8t plus 100, where w of t is measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. So for part D, I'm going to do the integral of 0 to 10, and then I'm going to do the w of t function, which is negative 3 over 10 t squared plus 8t plus 100 dt. So if I integrate this, I get negative 3 over 10 t cubed over 3 plus 8t squared over 2 plus 100t, solved at 0 to 10. And then plugging in my values, I get negative 3 over 10 times 10 cubed over 3 plus 8 over 10 squared over 2 plus 100 times 10. And then since each of these have t values in here, I'm just subtracting 0 by plugging in 0. And again, you could simplify this if you want, but to avoid any mistakes, I'm just going to leave it as is and then just make sure I put my units, which is words.